now we'll be talking on organic chemistry, part 1. And under this, we'll be looking at the introductory aspects into organic chemistry, where we talk on calculation of empirical and molecular formula, bonding in organic molecules, types of organic reaction, and isomerism. Before we talk on the calculation on empirical and molecular formula, we will look into different aspects in which organic molecules are being represented. And the first formula is the empirical formula. And what is empirical formula? Empirical formula is the simplest expression of organic molecules, which tells us about the percentage composition and the number of atoms present in the molecule. Then the second formula is molecular formula, which is actually based on the actual number of atoms in each molecule. And the last formula, which actually does not require calculation, is the structural formula, which tells us about the number of atoms bonded to the carbon atom in a molecule. Right now, we'll be going into solving of probably 2 questions on empirical and molecular formula. And here we have the first example, which is determine the empirical formula for a compound with the following elemental composition. How do you calculate empirical formula? Empirical formula is calculated from the composition data that is being given. As you can see here, we have 40% of the data composition for carbon, 6.72% for hydrogen, and 53.29% for oxygen. And how do we go about that? We write the symbols for the elements: carbon, hydrogen, and oxygen, and under it you position their percentage composition, 66.72 and 53.29. Now we divide their percentage composition by their relative atomic mass, and relative atomic mass for carbon is 12, and that for hydrogen is 1, and relative atomic mass for oxygen is 16. So when we divide 40% by 12, it gives us 3.333, and for our hydrogen we have 6.72, and for the oxygen we have 3.331. Now the next step is for us to divide our result here by the simplest or the least results, and from our results here we have 3.31 being the least, so here we have 1.0, 2.0, we have 1.0. Now our empirical formula will be in this way: CH2O. As you can see that the carbon is having just 1, the hydrogen 2, and the oxygen 1. So that this is our empirical formula. Okay. Then for the second question, where we'll be calculating the molecular formula. The question is, an organic compound has been found to possess the empirical formula CH2O and vapor density of 45. Calculate its molecular formula. The formula that we use in calculating our molecular formula is CH2O. Now that will be the molecular formula in brackets with our N equals to the relative equals to the molecular mass or molar mass. Now, in solving these parts, we solve them by their relative atomic mass, multiplying them with the subscript, which is carbon is 12 times 1, close the brackets, plus hydrogen, which is 1 in relative atomic mass, multiplied by the 2 here. Then our oxygen, which is 16 times 1, equal to our molar mass, which is also the same thing as the molecular mass. And from our question, we are given vapor density. So how do we derive our molar mass? So our molar mass equals to 2VD, which is 2 vapor density. Our molar mass equals to 2 times 9 times 45, which is 90. Now bring our 90 back to the initial equation, and here we're having 12 plus 2 plus 16 n equals to 90, which is 30 n equals to 90, and our n equals to 3. Now, molecular formula is actually a multiple of empirical formula, whereby having our n to be 3, we multiply our empirical formula with the number of n. So we have C three H6O3 for our molecular formula. So this is just the simple way in solving empirical formula and molecular formula. And now we go into bonding in organic chemistry. Bonding in organic chemistry, where we talk about the sigma bond and the pi bond. The sigma bond and the pi bond. The sigma bond is the bond in which carbon atom forms with 4 different atoms, and under the sigma bond we have 4 hybrid orbital that is being formed, which has the hybridization of sp3, and the structure or the geometry is a tetrahedral geometry with bond angle of 109.5 degree. That is for sigma bond. Then talking about pi bond, just as carbon atoms form single covalent bond with other atoms, it also forms double bond between its own atoms as well, whereby in the formation of the bond we have 3 sigma bond that is being formed, while the remaining lone pair electrons in the p orbital forms an overlap, and when the p orbitals of the 2 carbons form an overlap, then they result into the pi bond, and the hybridization formed here is sp2, and the structure is trigonal planar, and the bond angle is 120 degree. Okay, before, let me just make a little digression. For the hybridization structure and bond angle, this is peculiar to the alkanes family, while the hybridization under the pi bond, the structure and the bond angle is peculiar to the alkane family. We have a triple bond also, which is made up of 1 sigma bond and 2 pi bond, with the hybridization of sp and a linear structure, which the bond angle is 180 degree, and the family of the organic compound in that is the alkynes family. Right? Now, still on bonding in organic molecules, we're talking on bond fission. What do you understand by bond fission? From the word fission, fission means breaking. So that means bond fission is the breaking of the covalent bond that attaches or that binds a compound. And under bond fission, we have 2 types of fission. We have the homolytic fission, and we have heterolytic fission. Under homolytic fission, the breaking of the bond results into the 2 atoms that have been breaking to have each pair of each electron on their orbital. Taking for an example, for homolytic fission, when there is a breaking of bond between HCl, then the 2 has the electron, they have an equal sharing of the electron on their orbital. As you can see, the hydrogen is having an electron, while the chlorine is also having an electron. Then talking about heterolytic fission, this is a process whereby there's an uneven sharing of electron amidst the atoms. Taking HCl for an example as well, here we have the hydrogen having a positive charge and the chlorine taking the 2 electrons. Now, under heterolytic fission, the more electronegative atom takes the 2 electrons to itself. That is why we are having the 2 electrons being attached to chlorine. Alright. In the next video, we'll continue on where we stopped on bonding in organic molecule. Thanks.